Okay, so our next topic is going to deal with something called an exterior angle. So we've talked a lot about interior angles, the angles inside of a triangle. But what we're going to look at now are those exterior angles, and those are the angles that are formed by a side that is continued. So if we look at this angle here, so it's a side that's continued and the outside of another side. So this would be an exterior angle. If you take a look at the definition, I would recommend putting this into your vocab section for Unit 3. So put that definition, exterior angles, in. So go ahead, pause now, and get that definition. Okay, so hopefully you guys got that definition. Key things, it's that outside angle formed between a side and then an extended side. And it's also, important part, a linear pair with its adjacent interior angles. So if I was looking at this exterior angle, it would form a linear pair with this interior one. Okay? Key things of the exterior angle. So now, we got a theorem that relates to this exterior angle. And what that theorem says, so this is something that is in your notes that you guys can go ahead and cut out. So if you want, take a minute, pause, cut that out. Okay, so hopefully you got that cut out, glued into your notes now. So let's take a look at what this theorem says. It says the measure of an exterior angle of a triangle, so the exterior angle right here, is equal to the sum, so in your mind sum means add, of the measures of the two non-adjacent. So non-adjacent means not next to. Interior angles. So the angles that are not next to that one would be those two angles. So those are our two that are not next to angle 1 or that outside angle there. So, but here's what the theorem basically says. It says that if I take the measure of angle 1, I can set it equal to the measure of angle A plus the measure of angle B, and those two values should be equal. Now, I don't like to give you guys theorems and not prove them, so that other part of the cutout is the proof for that. Since I didn't want to make you write the whole thing, I gave you some parts to it already. So let's see if we can break down this theorem. Let's start with the given piece here. So given angle 1 is exterior to angle of triangle ABC. So that first part, like always in our proofs, that's our given. So we're going to look at next is it says that the measure of angle ACB, so that angle, let's give it a fun color here, that angle is right there, and angle 1, this angle right here, are going to be linear pairs. And it says that's because the definition of an exterior angle. Well, if you guys remember, it said that the exterior angle is a linear pair with its adjacent angle. So yeah, that makes sense. So if something is a linear pair, doesn't that mean it adds up to 180? We had a rule that told us that. And what that rule was called was this. The linear pairs, and hopefully some of you thought of it here already, conjecture. So remember, the linear pairs conjecture just said if I have linear pairs, they add up to 180. So what we're going to look at now is we're going to look at, well, if I say measure of ACB plus the measure of angle 1 is equal to 180, so we got that equals 180. Alright, so this next piece, they say that the measure of A, B, and this orange angle in here, ACB, is equal to 180 degrees. That's true by this triangle sum theorem. So yeah, that's all the angles inside of our triangle, right? So we got those angles there. So all those angles add up to 180. That makes sense, triangle sum theorem. Now this next piece, this is interesting. It says that ACB plus the measure of angle 1 is going to be equal to measure of angle A, measure of angle B, plus the measure of angle ACB. So we got to think about how they did that. Well, if you look, they're saying this angle, so we can say maybe if A is equal to B, 180, and then 180B is equal to C, then A has to equal C. Do you guys see that? How A here is equal to B, and B is equal to C, so that means that A must equal C. So if anyone can remember that property, give you a second, think about it. Alright, what that property is called, hopefully some of you got it. That transitive property. That one that said that I'm a nobody, so I must be perfect. So we got our transitive property. Alright, so now this next piece, if you guys notice, inside number 5 here, so basically they've taken this equation and they've kind of pared it down to get this one. And basically what they did was they said, well, I got an ACB here and I have an ACB here, so if I subtract that from both sides, then it would cancel out on both sides, and all I will be left with is this equation here. And conveniently, that's the equation I want to solve for. So the property they used when they subtracted was the inverse property of addition. So that's the proof. Because the interior and its adjacent exterior, these two angles add up to 180, and also because the three angles inside a triangle add up to 180, that means that this exterior angle plus these two interior angles should also add up, should be congruent to each other, actually. Alright, so that's our proof. Let's go ahead and try to apply this property now. So you guys should have a cutout here that looks exactly like this. And if you look at that cutout, go ahead and get that cutout glued into your notes. Take a second, pause if you need to. Okay, so looking at this property, we just said that an exterior angle is equal to the sum of the interior angles. So that means this red angle here is equal to the sum of these two. So all we need to do is write an equation that says that. So we're going to say that the exterior angle 2x minus 11 is equal to the sum of the interior angles x plus 72. So I'm just taking that theorem we just proved, writing an equation out of it, and now we just have to solve that equation. So to do that, we got to get our x's together, subtract x from both sides. We get x minus 11 is equal to 72. Now we get x by itself, so I'm going to add 11 to both sides. We get x is equal to 83. Now in this problem it does say find the value of x, but it also says find the measure of the exterior angle. So now that I know 83, I'm going to take that value and substitute it back into my exterior angle and get this. 2 times 83 is equal to, sorry, not equal to, minus 11. And I want to figure out what that's going to equal. So I solve that out. Just multiply 2 times 83. That's going to give me 166 minus 11. And 166 minus 11 will give me a final answer of 155 degrees. You can check yourself if you want. We know x is 83 here. So it's 83 plus 72 equal to 155. And it is. So it works out. Okay, let's check out letter B here. We're going to do the same thing. The exterior angle must equal to the sum of its two non-adjacent interiors. So we have to add x plus 110 is going to equal our exterior angle, 4x minus 7. Do the same thing. Get your x's together. So subtract x from both sides. And again, added our two interior angles to equal our exterior angle. So subtract x, we get 110 is equal to 3x minus 7. Add 7 to both sides. Cancels there, gets 117 there. 3x left over. Divide by 3, divide by 3. X must equal 39. And that's it. So those are two examples there. I want you guys to use those examples and see if you can use this exterior angle theorem as well as some other properties we already know about triangles to check out these example problems 5 through 14. So 5 and 7 probably pretty quick to do, but 13 and 14 might take a little more work. Give those a try, pause the video, and we'll come back and look at the answers. Go ahead and pause now. Okay, so hopefully you had enough time to check out those problems. Here's the work I have for each one. I'll kind of box them out so you can see where the work for one ends and the work for the other begins here. Okay, and there we go. Alright, so there's my 4 problems. So take a look at those, see if you have any questions. Remember, you can either ask Coach Pierce or you can text me on Remind if you have any questions for any of these problems. I'll try to get back to you as soon as I can. So you guys have a few extras to try, those even problems, if you want some more practice with those. But other than that, what we're going to do is now we're going to take a look at one more triangle property for today. So let's go ahead and try to find the property for the centroid. Find that video. It should be the next in the playlist.